Chapter 5. Shapes and Patterns. Geometry is commonly found in architecture. Bridges, buildings, towers, space stations, etc. have triangles as a part of their construction. Triangles hold the shape of these constructions very well and are fixed. We have already learnt about closed figures and polygons in the previous class. Let us revise. A polygon is a simple closed figure made up of line segments. Look at some examples of polygons shown below. A polygon with three sides in the figures given above is a triangle. Physical examples of triangles in our surroundings are: in mathematics, a triangle is defined as follows. A triangle is a simple closed plane figure formed by three line segments. In the figure, ABC is a triangle. A, B, and C are its vertices. AB, BC, and CA are its sides. Angle ABC, angle BCA, and angle CAB are its angles. Thus, a triangle has three vertices, three sides, and three angles. We use the symbol triangle to denote a triangle. Thus, triangle ABC means triangle ABC. This triangle can also be written as triangle BCA, triangle BAC, triangle ACB, triangle CAB, and triangle CBA. Thus, the order of vertices does not matter while describing a triangle. Classification of triangles. Triangles are classified in two ways, on the basis of sides and on the basis of angles. Classification on the basis of sides. Scalene triangle. A triangle in which all the three sides are unequal in length is called a scalene triangle. In the given figure, PQR is a scalene triangle because all the three sides PQ, QR, and RP are unequal. Isosceles triangle. A triangle in which two sides are equal in length is called an isosceles triangle. In the given figure, MNO is an isosceles triangle because the two sides MN and MO are equal. Equilateral triangle. A triangle in which all the three sides are equal in length is called an equilateral triangle. In the given figure, ABC is an equilateral triangle because all the three sides AB, BC, and CA are equal. Classification on the basis of angles. Right-angled triangle. A triangle in which one angle is right angle, that is equal to 90 degree, is called a right-angled triangle. In the given figure, PQR is a right-angled triangle because angle Q is equal to 90 degree. The side opposite to the right angle is known as the hypotenuse of the triangle, and the other two sides are called the legs of the triangle. PR is the hypotenuse and PQ and QR are the legs. Acute angle triangle. A triangle in which each of the three angles is acute, that is less than 90 degree, right angle, is called an acute angled triangle. In the given figure, angle K, angle L, and angle M are acute angles. So, KLM is an acute angled triangle. Obtuse angled triangle. A triangle in which one angle is obtuse, that is more than 90 degree, right angle, is called an obtuse angled triangle. In the given figure, PQR is an obtuse angled triangle because angle Q is an obtuse angle. Remember, in an isosceles triangle, two angles are equal. An equilateral triangle is an acute angled triangle, and the measure of its each angle is 60 degree. Two angles in each case of right-angled and obtuse-angled triangles are acute. Properties of a triangle. Property 1. The sum of the lengths of any two sides of a triangle is always greater than the length of the third side. Verification. Observe the triangles shown below. Measure their sides and fill in the table given below. Now complete the table given below. Conclusion. We conclude that the sum of the lengths of any two sides of a triangle is greater than the third side. Thus, three line segments can form a triangle only when the sum of the lengths of two smaller line segments is greater than the length of the lowest one. Note, the above result is clearly true when the sum of the lengths of two smaller sides is greater than the length of the longest side. Property 2. The sum of the measures of all the three angles of a triangle is 180 degree or two right angles. Verification. Draw a triangle PQR on a piece of thin cardboard and cut it out. Now label the three corners as 1, 2, and 3 and snip off the three corners of the triangle. With the help of the points you have marked, arrange the piece as shown on the next page. At the point Q, where angle P, angle Q, and angle R are placed together, the three angles together measure 180 degree. So, angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Thus, we conclude that the sum of three angles of a triangle is 180 degree or two right angles, 2 into 90 degree. Example 1. Is it possible to form a triangle whose sides are 5 cm, 8 cm, and 14 cm long? Solution. Let us consider three line segments of lengths 5 cm, 8 cm, and 14 cm. The sum of the lengths of two smaller line segments is equal to 5 cm plus 8 cm is equal to 13 cm. The length of the longest line segment is equal to 14 cm. Clearly, the sum of the lengths of two smaller line segments is not greater than the length of the longest line segment. So, it is not possible to form a triangle by the three line segments of length 5 cm, 8 cm, and 14 cm. Example 2. Which of the following sets of angles represent the angles of a triangle? A. 70 degree, 80 degree, 50 degree. B. 35 degree, 40 degree, 100 degree. C. 45 degree, 65 degree, 70 degree. Solution. A. Since the sum of three angles is equal to 70 degree plus 80 degree plus 50 degree is equal to 200 degree. Since 210 degree is greater than 180 degree, this set does not represent the angles of a triangle. B. Since the sum of three angles is equal to 35 degree plus 40 degree plus 100 degree is equal to 175 degree. Since 175 degree is less than 180 degree, this set does not represent the angles of a triangle. C. Since the sum of three angles is equal to 45 degree plus 65 degree plus 70 degree is equal to 180 degree. So, this set represents the angles of a triangle. Example 3. The two angles of a triangle XYZ are given as angle Y is equal to 60 degree and angle Z is equal to 75 degree. Find the third angle. Solution. We know that the sum of three angles of triangles is 180 degree. So, angle X plus angle Y plus angle Z is equal to 180 degree, or angle X plus 60 degree plus 75 degree is equal to 180 degree, or angle X plus 135 degree is equal to 180 degree. Therefore, angle X is equal to 180 degree minus 135 degree is equal to 45 degree.